Okay, so let us start. Put on your cameras. Rudra, where were you yesterday?
Ma'am, actually there was a network problem, so I can't join.
So you should at least message, na? WhatsApp message तो चलता है.
मैम पर मैसेजेस नहीं आ रहे थे, वाईफाई पूरा बंद था ऐसा.
Text message चलता है. Message तो करना चाहिए ना कि भाई क्या है. I've sent the link of yesterday's recording. Okay, go through the recording.
Okay, ma'am.
Okay, so all of you, when did you go through the subject? Whatever we did yesterday. Okay, so Janvi, what is liquid pressure? P is equal to formula. Pressure on area. P is equal to pressure in liquid is equal to. Yes, Ayan.
Ma'am, height rho g.
Huh?
Height rho g.
H rho g. Yes.
H rho.
H rho g. Yes. Okay. So, what is thrust? Thrust.
Ma'am, can I say?
Ma'am,
Yes,
can I
sir.
say?
Ma'am, thrust is the force which is a normal force. Is the thrust is the force which is perpendicular or normal to the surface.
Yes, the force acting perpendicular normal to the surface. Okay, Janvi, what is the unit of thrust?
One unit of thrust.
Yes.
Newton.
Hello? Can you say loudly? Janvi, what is unit of thrust?
Ma'am, Newton.
Newton. Okay. Unit of thrust is Newton. Ayan, what is unit of pressure?
Ma'am, Pascal.
Pascal. Correct. What is the CGS unit of pressure, Ashi?
Can I? Ma'am, can I?
Oh, wait. CGS unit of pressure, Ashi?
Ma'am, what is it? Yes, ma'am. Pressure is equals to
Don't rub
10.
your eyes. Don't rub your eyes. Don't rub your eyes.
Pressure is one pressure is equals to 10 power
No,
5.
CGS unit of pressure.
Ma'am, it is 10 power 5 then, right?
No, that is 1 Newton is equal to 10 raised to power 5 done. But I'm talking about CGS unit of pressure. Ayan?
Ma'am, 9 centimeter square.
9 per centimeter square. 9 per centimeter square. What we did yesterday. So we did pressure, that is thrust, is the force acting normally on the surface, and it is a vector quantity. Then we did unit of thrust, that is Newton. Then we did MKS unit, that is kgf, and then CGS unit is gram force. Then pressure is thrust acting per unit area. So pressure is thrust acting per unit area. So if the area of contact increases, pressure decreases. Area of contact decreases, pressure increases. And pressure is a scalar quantity. Pressure is a scalar quantity. we did the units of pressure, that is Newton per meter square, that is 1 Pascal. And then we did dyne per centimeter square. And 1 dyne per centimeter square is equal to 0.1 Newton per meter square. Then other units of pressure, that is gram force per centimeter square or kilogram force per meter square. Then 1 bar is 10 raised to power 5 Newton per meter square. Then millibar, then atmospheric pressure, that is 76 centimeter of Hg, and 760 mm of Hg, that is equal to 760 torr. So then we did, in order to decrease the pressure, in order to increase the pressure, we have to decrease the area of contact. So, and in order to decrease pressure, we have to increase the area of contact. And in that case, we did the caterpillar wheel of the military tanks, broader feet of camel, slippers are placed underneath the railway track. Then foundation of the high-rise buildings are broader. Then factors affecting the pressure, the area on which the thrust is applied, the larger the area, the lesser is the pressure exerted, and the larger is the thrust, the more is the pressure exerted. Then we did the fluid pressure. Pressure in fluid is again equal to force upon area, but the force is the weight of the liquid acting, and weight of the liquid is mg upon A, and mg is V rho G upon A. And V can be written as area of cross-section into the height into rho and G, and so A and A gets cancelled. And so we get pressure is directly proportional to height, density, and gravity. So pressure in liquid is independent of shape and the size of the vessel and the area cross-section on which it acts. This is very, very important. Pressure is independent of the shape and the size of the vessel and the area of cross-section on which it acts. We had derived this formula, and then pressure exerted by the liquid column. So the total pressure at the depth of the H will be atmospheric pressure plus pressure due to liquid column. Then the factors affecting that pressure at a point. So we did, it is directly proportional to the height. More is the depth of the liquid column, more is the density, more is the pressure, more is the density of the liquid, the more is the pressure, and it depends upon the acceleration due to gravity. Then we did laws of liquid pressure. The first one, that is pressure is directly proportional to the height, that it increases with the depth. Deep sea divers, they wear special suits to withstand the large pressure in sea. Then dams have broader walls on the at the base to withstand the high pressure. Then water tank supplies are placed high, so that the liquid pressure is more. Then the gas bubbles rise as increase in the size as they rise up. This was very important, and we did Boyle's law. So according to Boyle's law, pressure volume of a gas is inversely proportional to pressure. More is the pressure, the lesser is the volume. So this one is an experiment to show that the liquid pressure is highest at the base. The more is the height of the liquid column, the pressure is high, and so the strongest jet is from the lowest part. Then laws of liquid pressure. Second, we did the pressure is same at all the points on a horizontal plane. And then we did that pressure about a point is same in all direction. Then we did pressure is directly proportional to the density. Pressure is independent of the shape and the size of the vessel, and liquid seeks its own level. Liquid seeks its own level. Then so now today we are going to do the transmission of pressure in liquid. This is very important law. So Pascal's law. So Pascal experimented and found out that the pressure exerted anywhere in a confined liquid. Confined liquid matlab liquid चारों तरफ से बंद होना चाहिए. There should not be any outlet. The liquid should not come out. So when the pressure is exerted anywhere in a confined liquid, it is transmitted equally and undiminished in all directions throughout the liquid. So this is a piston. So in this, you see, so there is a piston A and there is a piston B. So if I apply a force of 10 Newton at A, then the pressure exerted, and this area is 1 centimeter square. So the pressure exerted is 10 Newton per centimeter square. The same pressure will be transmitted throughout the liquid, and it will come to the piston B with the pressure 10 Newton per centimeter square. If I apply a pressure, so if I apply a pressure of 20 Newton, if I apply a force of 20 Newton here, and the area of cross section is 1 centimeter, so the pressure applied will be equal to 20 Newton per centimeter square, and this pressure will be transmitted throughout the liquid, and it will come here at B. The same pressure will be applicable, that is 20 Newton per centimeter square. Are you understanding this point? तो पास्कल ने क्या बोला? पास्कल ने बोला, if the pressure is exerted anywhere in a confined liquid, the term confined is very, very important. Confined मतलब enclosed liquid, कहीं पे भी leakage नहीं होना चाहिए. So it is in the confined liquid, the pressure is transmitted equally and undiminished in all directions throughout the liquid. Why your cameras are not on? Should I remove you from the meeting?
Ma'am,
Yes, Janvi.
ma'am, actually I have some itchiness in my eyes, so can I just keep my video off for today?
Okay.
Thank
What
you,
about
ma'am.
Ayan and Rudra?
Yes, ma'am.
Our video is on now.
Okay. So,
My video is also on.
so पास्कल का लॉ समझ में आया? पास्कल ने क्या बोला? अगर हमने लिक्विड को कन्फाइन किया, कन्फाइन मतलब उसको क्लोज किया, एनक्लोज किया, एंड अगर हम जगह पे प्रेशर लगाएंगे, वो सेम प्रेशर थ्रू आउट द लिक्विड जाएगा. थ्रू आउट द लिक्विड द सेम प्रेशर विल बी एक्सर्टेड. प्रेशर की बात कर रहे हैं हम लोग. समझ में आई बात? सो अगर मैंने पिस्टन ए पे 30 न्यूटन per centimeter का pressure apply किया, what will be the pressure at the piston B? What will be the pressure at piston B?
Can I
It will
say?
be same.
Ma'am,
It will be
same. If over there is
same.
30
इतनी बात
Newton
समझ में आ गई
per
आपको?
centimeter cube square, यहाँ पे in B also it will be the same.
Okay. Now, pressure is equal to force upon area, right? Or thrust upon area. So what is thrust or force that is equal to pressure into area? है ना? So thrust is pressure into area. So अगर मैंने यहाँ पे suppose करो, मैंने यहाँ पे, यहाँ का एरिया है 1 सेंटीमीटर स्क्वायर और यहाँ का एरिया है लेट अस से 20 सेंटीमीटर स्क्वायर. हमने पिस्टन ए पे सपोज करो मैंने 20 न्यूटन का फोर्स अप्लाई किया पिस्टन ए पे, तो पिस्टन बी पे मुझे कितना फोर्स मिलेगा? पिस्टन बी पे कितना फोर्स मिलेगा? सो उसके लिए हमको पहले प्रेशर फाइंड करना. व्हाट इज द प्रेशर इन ए? प्रेशर एट ए, force applied is 20 Newton, area of cross section is 1 centimeter square.
20 Newton upon centimeter square.
So the pressure will be 20 Newton per centimeter square. So what is pressure at B?
Ma'am, can I say?
Yes.
Ma'am, we will multiply
rub your
20
eyes.
into 20. Like
But first I want the pressure. Pressure is 20 Newton per centimeter square. Now what will be the force? Force is equal to pressure into area. So pressure kitna tha? 20 Newton, area 20. So it becomes 400 Newton. अगर हमने यहाँ पे 20 न्यूटन का फोर्स अप्लाई किया, पिस्टन बी पे हमको 400 न्यूटन का फोर्स मिल रहा है. So isn't it a force multiplier?
Yes, ma'am.
It's a force multiplier. हाँ जानवी.
Ma'am, could you please explain this again, the formula one with you?
What is the formula for pressure? What is
P
the
is
formula
equals
for
to F upon A.
F upon A? So what is F?
P into A.
P into A. So what is Pascal saying? Whatever pressure is applied at A, it will be transmitted equally and undiminished till B.
Yes.
So pressure applied will be the same. So if I apply a 20 Newton force here and area of cross section is 1 centimeter square, so the pressure applied is 20 Newton per centimeter square. Same pressure is transmitted to B, but area of B is 20 centimeter square. So what will be the force developed at B? That is 20 into 20, 400 Newton force.
Okay, ma'am.
Clear?
Yes, ma'am.
Okay, let us do one more example. Please pay attention. The area of cross section at A is 5 centimeters square. Area of cross section at B is, let's say, 50 centimeters square. I apply a force F1 at A. So the force F1 at A, let us say, is 10 Newton. So what is pressure at A? Yes, Rudra?
Can I say?
No, Rudra. What is pressure, Rudra? Force upon?
Area
So what is force upon area? What is force?
10
What is area?
5 centimeter.
So for that pressure
Newton.
developed is 2 Newton per centimeter square का
Right.
pressure develop हुआ. So what is the pressure at B? According to Pascal's law, the pressure is transmitted equally and undiminished throughout the confined liquid in all directions. So what is pressure at B?
Ma'am, so 2 Newton centimeter square.
Very good. 2 Newton per centimeter square. But what is area at B?
50 centimeter.
So what will be the force developed at B?
Two into
100 Newton.
100. सबको समझ में आ गया?
Yes,
Is it
ma'am.
clear for everyone?
Yes, ma'am.
Ayan,
Yes, ma'am.
Ashi?
Yes, ma'am. I understood.
Okay. So Pascal's law, according to Pascal's law, P1 is equal to P2 and therefore F1 upon A1 is equal to F2 upon A2. ठीक है? According to Pascal's law, P1 is equal to P2 and so F1 upon A1 is equal to F2 upon A2. आपको तीन चीजें दी रहेगी, आपको fourth find out करना रहेगा. समझ में आ गई बात?
Yes, ma'am.
Out of these 4 parameters, three will be given to you and you have to find out the fourth one. Any doubt in this? So now, how do we apply? So this is the demonstration of Pascal's law. So, as एक piston या spherical piston, and then there are holes made at different position, and then you fill it with liquid, apply a pressure on this, then through this hole, the jets will come out with the same force. The jets will come out with the same force. So we apply application. इसमें आपका second ये जो part है, इसमें आपको detailed study नहीं करना है about the various instruments which we are using. We will just do the application of Pascal's law. So hydraulic machines such as on Pascal's law of transmission of pressure in liquid. Okay, so hydraulic brakes, hydraulic machine, hydraulic jack, hydraulic press, all these are based on Pascal's law. Application of Pascal's law. So a small force is applied on a smaller piston. It is transmitted to produce a large force on a bigger piston. This is what we did. So according to Pascal's law, P1 is equal to P2. So F1 upon A1 is equal to F2 upon A2. So since A2 is greater than A1, F2 will be greater than F1. Clear?
Yes, ma'am.
So we will do the numericals. So what all formulas do we have? So first formula we have force is equal to mass into acceleration or equals to mg. Then second formula we have pressure is equal to force upon area. Then third formula we have pressure in liquid is equal to H rho G. Then fourth formula we did is P1 equals to P2 according to Pascal's law. So F1 upon A1 is equal to F2 upon A2. Correct? So these are the formula that we have used. Now, so look at the numerical one. So a hammer.
Ma'am,
Yeah.
ma'am, you are doing the numericals
I
of
am.
the exercise which are given.
Yes. 4A.
Okay.
So a hammer exerts a force. So F is given 1.5
1.5
Newton.
Newton.
And there are two nails, A and B. Nail A has, the tip has an area of cross section 2 millimeter. And nail B has 6 millimeters square. Calculate the pressure on each nail. Now, first of all, this is millimeter square. We have to convert into meter square. So 1 millimeter square is equal to 1 into 10 raised to the power minus how many times?
Ma'am, can I say?
Yes.
Ma'am, -5, sorry, 6.
क्योंकि देखो 1000 millimeters make 1 meter ना.
Ma'am,
Ma'am.
0. Ma'am, 2 into 10 minus
Okay.
5.
So 1000 into 1000, so it becomes 1 millimeter square is equal to 10 raised to power minus 6 meter square. Okay. So
Yes, ma'am.
Ma'am,
what
but
is the
there
pressure
we will
at
put
A?
5 zeros, na? So
Why 5 zeros? 6 zeros आया ना 1 2 3 1 2 3.
मैम उसमें अगर हम 2 ले लेंगे तो
2 तो अभी हम यहाँ पे लगाएंगे ना.
हाँ ठीक है मैम, बराबर है।
1.5 upon 2 into 10 raised to power minus 6. So अभी ये हो गया 10 1.5 into 10 raised to power 6 divided by 2. So it becomes 0.75 into 10 raised to power 6. That becomes 7.5 into 10 raised to power 5 Newton per meter square. That is equal to 7.5 into 10 raised to power 5 Pascal. सेकेंड वाले का क्या होगा? Pressure at B. Is it clear?
Yes मैम।
Rudra, switch on the camera. So please write it down. 1 millimeter square is equal to 10 raised to power minus 6 meter square. And 1 centimeter square is equal to 10 raised to power minus 4 meter square. कैसे आया? Because 1 centimeter into 1 centimeter, that is equal to 100 centimeter into 100 centimeter. तो अगर हम convert करेंगे, so 1 centimeter square is equal to 1 by 100 into 100. So that is equal to 10 raised to power minus 4 meter square. So the next question. Block of iron of mass 7.5 kg. So what we have mass. And dimension is given. Dimensions will be length into breadth into height, and that is given to be 12 into 8 into 10. Is kept on a tabletop on its base of side 12 centimeter into 8 centimeter. So area of contact. What is area of contact?
Tabletop.
12 into 8 centimeter square.
Yes, ma'am.
Now, G is given 1 kgf is equal to 10 Newton and mass is 7.5 kg. So what is thrust? Thrust is equal to Formula quickly.
Ma'am, pressure into area.
प्रेशर इंटू एरिया तो ठीक है, पर यहाँ पे हमारे पास प्रेशर नहीं है, और भी मैंने दिया था, थ्रस्ट इज इक्वल टू फोर्स, फोर्स इज इक्वल टू mg, दिया था ना पहले वाले में.
हाँ मैम.
Look here, force is equal to ma, force is equal to mg.
Yes ma'am.
So mass है हमारे पास, mass of the body है कितना?
Ma'am 7.5 kg.
E कितना है?
mg, it is 10 Newton.
10 न्यूटन. तो फोर्स कितना हो गया?
75 Newton.
Now find the pressure, quickly find the pressure. Any doubt? Someone has to tell me this one. A vessel contains water up to a height of water is 1.5 meter. Density of water is given 1000 kg per meter square, per meter cube. And G is given 9.8 meter per second square. The area of the base of the vessel, area of cross section is given 100 centimeters square. First question is to find the pressure. What is the formula for liquid pressure?
Ma'am,
H rho G.
H rho G.
You have H,
Yes,
Yes
ma'am.
ma'am.
you have rho,
Yes, ma'am.
you have G.
Yes, ma'am.
Yes, ma'am.
Quickly find out.
Ma'am, I got the answer.
So now find out the pressure. What's the formula for pressure?
H rho G.
Sorry, now find out the thrust. That is the force.
Ma'am, I got both.
Good. Did everybody get it? कितना आंसर रुद्र?
Ma'am, pressure is 1.47 into 10 raised to 4 Newton meter square.
Per meter square. And then what is the thrust? What is the force?
Ma'am, thrust is 147 Newton.
Yes, pressure into area. But area हमारा सेंटीमीटर स्क्वायर में था. One centimeter square is equal to 10 raised to power minus 4 meters square.
Yes, I got the answer.
Okay, next question. Do you have math class?
Yes, ma'am.
What time? 7 o'clock?
Ma'am, wait a minute, I'll tell you at what time.
Ma'am, 7:40 p.m.
7:40 p.m. Okay, so I will take just 15 minutes more. Question 4. The base of the metal cylinder is vessel area. Area of cross section is given 300 centimeters square. Density of water is given 1000 kg per meter cube. Height of the liquid is given 6 centimeter, that is equal to 0.8 0.06 meter. So same thing, can you find pressure? And can you find thrust?
Yes, ma'am. We can find pressure.
Now, the next one. Question number 5. Calculate the height of water column. H you do not know, which will exert on its base the same pressure as exerted by 70 centimeter column of mercury. Pressure due to 70 centimeter of Hg is equal to pressure due to water column. So what is this? So P1 is equal to P2. So H1 rho 1 G is equal to H2 rho 2 G. G and G will be cancelled because it is at the same point. So if you have height 1, if you have height 2, you can find out H2 if you have this. Clear?
Yes, ma'am.
Okay. So question number 5, B part, the height of the water column will not change because pressure is independent of the area of cross section. It is independent of the area of cross section. Let's see question number 6. You have to complete this and send me a PDF, okay? Next class will be, tomorrow will you people be free? 6 to 7?
Yes, ma'am.
Okay, question number 6. The pressure of water on the ground floor is 40,000. So pressure is given 40,000 Pascal. And ground floor. Pressure first floor is given 10,000 Pascal. So find the height of the floor. So difference P ground minus P1 is equal to H rho and G. So 30,000 is equal to H हमको नहीं पता, rho हमको पता है, G हमको पता है. So you will get H is equal to 3 meter. A simple U-tube contains mercury at the same level in both the limbs. ये हमारा U-tube है. Mercury at the same level, है ना? दोनों में mercury इतना ही भरा. So this is Hg. If water is poured to a height of 13.6, यहाँ पे पानी डाल दिया. Height of 13.6 centimeter in one arm. How much will be the rise of mercury level? This mercury level should go up. So how much will be the rise here? How much will be the rise here? So pressure due to water column, P of water will be equal to P of mercury. Do you agree?
Yes, ma'am.
So same thing, H1 rho 1 G is equal to H2 rho 2 G. G and G cancel हो गया. H1 rho 1 यहाँ पे क्या है 13.6 into 1 is equal to H2 हमको नहीं पता, इसकी डेंसिटी 13.6 होती है, ये और ये कैंसिल हो गया. So mercury column H2 will rise by 1 centimeter. Mercury column will rise by 1 centimeter. Question number 8 में समझा देती हूँ. 9, 10, 11, 12, 13, 14 will be your homework. Now 8, 9, 10, these all you do. I will show you question number 11. Question number 11. The diameter of the neck of the bottle and this is the base. And the bottom of the bottle, यहाँ का diameter is given 2 centimeter diameter. And यहाँ का diameter is given 10 centimeter. The bottle is completely filled with oil. If the cork in the neck is pressed by a force, so यहाँ पे एक cork जो लगाया, so it is pressed by a force of 1.2 Newton का नीचे force लगाया. No 1.2 kgf. kg of force is applied. So what is the force here? So Pascal's law क्या कहता है? According to, you have to write, according to Pascal's law, pressure 1 is equal to pressure 2. Pressure is transmitted equally and undiminished. So what is pressure at neck region? 1.2 kgf upon 2 centimeter is equal to, यहाँ का force हमको नहीं पता, but area पता है. Sorry, area लिखना है.
Diameter is circumference, right? So how will
No, diameter is not circumference. Diameter is the diameter. You have to find the area. Area is equal to pi r square. So F1 upon A1 is equal to F2 upon A2. F1 कितना है? 1.2. Area कितना? Pi. R यहाँ का कितना हो गया? 1 into 1. F2 we do not know. Area कितना हो गया? Pi into 5 into 5. Diameter is 10, so radius is 5. The diameter is 2, so radius is 1. You have to be very careful about this.
ma'am, can we not write 20? Sorry, that
22 by 7.
yes,
जरूरत नहीं, नोट साइड कैंसिल हो रहा है ना ये. हम क्यों मल्टीप्लाई करेंगे? So 1 into 25 is equal to F2. So F2 55 in hand, 25, 30 kg F force. 30 kg of force. So did you people understand?
Yes, ma'am.
So by tomorrow, I want you to complete the entire numericals. And tomorrow, I'll be discussing the question answers, all the give reasons. So you have to take down. And I'm sending the PDF. उसपे से आप पूरा note कर लो. Okay.
Okay, ma'am.
So we stop here. Tomorrow, 6 o'clock. Okay. Join on time, please.
okay, ma'am. Thank you.
Bye.
Bye.
अच्छा, chemistry में क्या शुरू किया?
Ma'am, still not started anything.
Oh.
From
आप लोग का
next,
final, आप लोग का एग्जाम होगा ना फर्स्ट वीक में सितंबर.
yes, ma'am. From Monday, ma'am is going to start.
And physics, you started with this?
Yes, ma'am.
Or finished the first part or what?
No, ma'am, means